Morning, everyone. Myself, Monica Nansupriya, Assistant Professor in the Department of Electrical and Electronics Engineering. In this semester, I'm handling W3017 Embedded C Programming in the Regulation 2021. Today, we are going to see about the stepper motor interfacing, an important topic in embedded system and automation. A stepper motor is a special type of motor that rotates in a fixed angular steps rather than continuously like a normal DC motor. By controlling these steps through the 8051 microcontroller, we achieve the precise position controller. So we are having the many applications like printers, CNC machines, robotic arms, 3D printers, camera positioning systems. So we are having n number of stepper motor applications. And first, we have the introduction of to the stepper motor. The stepper motor converts the electric pulses into the mechanical movement. So each pulse sent from the microcontroller, the one step sent from the microcontroller rotates the motor by a small fixed angle, that is the step angle. If the step angle is 1.8 degree, then the revolution is 200 steps per revolution. If it is the one complete rotation is 360 degree. So we are having the step angle is 1.8 degree means we are having the 200 steps per revolution. For one revolution, we are having the 200 steps. So for a constant motor, stepper motor, we are having the 200 steps per revolution. So the motor requires 200 pulses to complete one full rotation. So this makes stepper motors ideal for application requiring the exact positioning. The next one is the classification. By construction, it is having the permanent magnet, variable reluctance, hybrid. By the number of steps, it converted into 4-step motors and 8-step motors. In hybrid stepper motor, combine the advantages of permanent magnet and variable reluctance motors and are commonly used in the industrial systems. First one is the permanent magnet stepper motor. Uses a rotor made of the permanent magnet. So the stator coils becomes a electromagnet when energized. The rotor aligns with the magnetic field. So sequential energizing of coil rotates the rotor step by step. So the advantages is good holding torque, the simple construction, and widely used in the small automation projects. So the variable reluctance stepper motors also have a soft iron rotor without the permanent magnets. So this also the rotor moves to the position of minimum magnetic reluctance, no residual torque when power is removed, faster response than PM motors, permanent magnet motors. So application is also the precision instrument and the positioning systems. And the next one is the it is a permanent magnet and the wiring configuration of the 4-step motor. And this is the variable reluctance of the motor. The 4-step stepper motor has a 4 coils. These coils are energized in the sequence. So the control panels that is 1 0 0 0 0 0 1 0 0 0. These are the 4 control panels, and each patterns activates one coil and moves the rotor by one step. These are the configuration and these are the fundamental principle is the coil becomes an electromagnet, the opposite poles attract. So the like poles repel. So the rotor moves towards the energized coil. By energizing the coil, one after the other, motor starts to rotate. These are the fundamental principle. And the direction of the control is also the coils are energized in the forward sequence. It must rotate in the A, B, C, D. And the counterclockwise rotation, the sequence is reversed, that is D, C, BA. So the changing the sequence changes in the direction of the rotation. Then the programming concept is also the microcontroller sends the binary values to the output port. These values energize the specific motor coils through driver circuits such as ULN3003A. So why use the driver circuit? This is a program, and these are the programs just used for the control and the motor data. While if the control is equals to 1, the motor will start to rotate. So these are the driver circuit, and it functions of the driver circuit is amplifies the current and protect the microcontroller, and also provides these way safe switching. So these are the program structure, and the registered the 51.h. It includes the 8051 definitions, and the motor data refers to the port 1 definition. The control is connected to the port 2 definition. Though, so the main function is the control is equals to 1, the motor data equal to 0. The purpose is enables the motor control and initialize the motor output to 0. The infinite loop is while loop. That is, if control equal to 1, this loop continuously checks whether the motor should run. If the control is set to 1, the motor operation remains active. What is the output? The motor data is equal to 0x88. This sends the binary pattern to the port 1. This connected the driver energize the appropriate motor control, causing the rotor to move. So the complete program working is from the initialize the control signal, set motor data to 0, and enter the infinite loop, check the control signal, send the output pattern. These are the real-time applications. Like, say 3D, already we know that no 3D printers, CNC machines. These are all the real-time applications, and these are the references. We will see the next topic in the next video. Thank you.